Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to demystify mathematics and tackle the age-long phobia associated with this important subject, one topic at a time. Before I continue, I wish to appreciate you for being faithful subscribers to this beautiful channel of ours. Thanks for staying true to us. We continue today on our topic, partial fractions, which we have had in the past two videos. Partial fraction, as a way of summarizing, is a reverse process of getting the component of an already solved or simplified algebraic fraction, either by addition or subtraction. So the idea of partial fraction is to reverse the process and by breaking down the answer into the component fractions that form the fraction. And we have looked at two basic categories under partial fraction. The first being the case where the denominators have distinct factors as denominators. The second case is the last video in which we have repeated factors as denominators. Without wasting much time, today we go deeper into the third case, and that has to do with non-factorizable denominators. So on the board we have resolve 3x plus 2 over x plus 1 bracket x squared minus 2x plus 1 into partial fraction components. So we have two factors as it were here. We have a distinct factor x plus 1 and another factor x squared minus 2x plus 2. Now this factor here is quadratic expression. However, on a closer look, we see that this particular expression cannot be factorized. And how do we get to know that? Remember, in one of our videos in quadratic equation, specifically factorization method, we did mention then that it's not every quadratic expression that can be factorized, but there are some that will not be factorizable. And how do we know this? The test for factorizability, whereby we test by using b squared minus 4ac. If the answer we get from that is a perfect square, hence that quadratic expression can indeed be factorized. If, however, b squared minus 4ac does not give us a perfect square, hence that expression cannot be factorized. So that is what we bring in here. If you look at x squared minus 2x plus 2, it certainly cannot be factorized. By quickly testing b squared minus 4ac, b here is minus 2, so we have minus 2 all squared minus 4. A is 1 and c is 2. So this minus 2 squared is 4, minus 4 times 1 times 2, minus 8, which is minus 4. Clearly, this is not a perfect square. Hence, this falls in the category of non-factorizable denominator. So, how do we approach problems of this category? That exactly is the essence of our lesson today. So, we start by saying 3x plus 2 over x plus 1 x squared minus 2x plus 2. As usual, we use a letter a over x plus 1. That's for the first factor. Ideally, each factor should have a letter from previous videos. So x plus 1 is a factor, it has its own letter. If this were factorizable now, we would have broken down into two factors, whereby b, the next letter to a, we have one factor, then c, we have the other factor. But since this has been established to be non-factorizable, we are going to simply have something like this: b x plus c over x squared minus 2x plus 2. This is the trick when you have non-factorizable. So let's proceed as before. After this step, we have x plus 1, then x squared minus 2x plus 2, as usual. So we simplify this by having x plus 1 gone. We have this left, and that is a bracket x squared minus 2x plus 2 on one hand. Then here we have the entire factor here crosses out this. We have bx plus c times x plus 1. So at this juncture, we can simply say that, of course, 3x plus 2 over x plus 1 x squared minus 2x plus 2. So at this juncture, we can easily compare the numerators since both denominators are the same, literally. So we have 3x plus 2 being equivalent to a s squared minus 2x plus b x plus c, then x plus 1. So what is left for us now is to open the bracket there. We have a s squared minus 2ax plus 2a. Opening the first bracket. The second bracket, we have bx squared plus bx plus cx plus c. So at this point, we can collect the terms in terms of degrees. So we have here a x squared plus b x squared for the x squares, then minus 2ax plus bx plus cx. Then lastly, the constants, we have 2a plus c. Again, to be sure we have not left out anything, we've gotten how many terms here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. As a mathematics candidate or student, you must always have an inbuilt checks and balances to more or less assess yourself or appraise yourself as you go on before you go too far and submit a solution full of errors. So at this junction, I can now properly factorize a plus b x squared plus minus 2a plus b plus c x, then the constants 2a plus c is now properly written in the standard form, power 2, power 1, and constant, whereby you can now directly liken to the left hand side. So this is where the comparing or comparison comes in. So comparing coefficients. So when you pick the x squared on the right hand side, its coefficients are, or we have a plus b, that's coefficient. So what is the corresponding coefficient on the left hand side? Nothing, 0. We call that equation 1. Similarly for x, the coefficient there is minus 2a plus b plus c, and the coefficient on the left hand side here is 3 for x. Then lastly, for the constant, we got 2a plus c on the right hand side, and the constant on the left hand side is 2. So we have equations 1, 2, 3 to contend with. So we are now in the aspect of solving a system of linear simultaneous equations. So let's move on. Solving equations 1, 2, 3 for the letters A, B, and C. Now, all we need to do here is to simply solve by looking at equation 1 first, which luckily for us, a plus b is 0. So we can say that from 1, a becomes minus b. That is a equals to 0 minus b. We then are going to substitute this value of a, b minus b, into equations 2 and equation 3, one after the other. So if I substitute a equals minus b into equation 2, I'm going to have minus 2. A is minus b, remember? So the a is being replaced by what? Minus b. Then plus b plus c, which equals to 3. So this becomes 2b, because minus times minus is plus b plus c equals to 3. Hence, 3b plus c equals to 3. We call that equation 4, because we stopped at 3. In a similar vein, we substitute a equals minus b again into equation 3. And equation 3 says 2a plus c equals to 2. Hence, we have 2 brackets minus b, which is my a now, then plus c equals to what? 2. Hence, minus 2b plus c equals to 2. We call that equation 5. Hence, we have to solve equations 4 and 5 simultaneously, because they will be reduced to the same letters, b and c, b and c. So we have 3b plus c is 3, and minus 2b plus c is 2. This equation 4, this equation 5. So luckily we have c having the same coefficients. Hence, we can easily say equation 4 minus equation 5. Hence, we are going to have 3b minus 2b. C minus C, 0, equals 3 minus 2. This gives us 3b plus 2b being equals to 1. So 5b is equals to 1. Hence, b is equals to 1 over 5. If b equals to 5, 1 over 5 rather, we have actually have gotten a. Because a, recall a is minus b. Hence, that's minus 1 over 5. So a is minus 1 over 5, b is actually 1 over 5. And that leaves us with c. So to get c, we are at liberty to use any equation that has c involved. So let's pick, for example, equation 5. So using 5, which says that minus 2b plus c equals to 2. Our c becomes 2 plus 2b. When we make c the subject there, that will be plus 2b. And luckily, we've gotten our b, which happens to be 1 over 5. So we have 2 plus 2 over 5. And that will be 12 over 5 as our c. Hence, the three values have been gotten. A, minus 1 over 5. B, 1 over 5. And C, 12 over 5. And with that, the stage is set for us to simply replace the letters A, B, and C in the standard equation. So we recall, finally, that 3x plus 2 over x plus 1 bracket x squared minus 2x plus 2, which was written as a over x plus 1 plus bx plus c over x squared minus 2x plus 2 now becomes, replacing the values, minus 1 over 5 over x plus 1 plus b 1 over 5x plus c 12 over 5 all over x squared minus 2x plus 2 finally becomes minus 1 here over 5, then x plus 1. So writing this in a proper way, this denominator can actually come here. Then similarly, we have 5 as denominator common to both terms here. Can simply say x plus 12 left as numerator, then the 5 comes here, x squared minus 2x plus 2. And that is the last stage of the solution to this important example, demonstrating how to go by it. We have non-factorizable denominators in partial fraction. And with that, we've come to the end of the lesson for today, which I believe is quite interesting, enlightening, and most importantly, fun. If you had fun, much as I did here, as I expect anyway, I want you to please subscribe, like, share, and most importantly, tune on your notification button so that you'll be the first to know when our next video shall be dropped. And the next video is going to be the last case of partial fraction. Is where we have equal degrees of numerator and or greater degree of numerator than the denominator. Thank you and stay blessed.